It's a pleasure to be able to join you here today. Can I first acknowledge the traditional peoples of the land where we meet, the Eora people of the Gadigal Nation, and offer my respect to their elders past and present. So I have the privilege of leading Rio Tinto's Growth and Innovation Division. It has a wide-ranging brief spanning the entire life cycle of our assets, from exploration through studies and construction, through optimization and technical support, right through to closure and rehabilitation. This remit also includes management of our global information technology, productivity, internal management consulting, automation and data science teams. Together in partnership with our teams from Rio Tinto's product groups, we help drive relentless company-wide productivity improvements. The mining industry is at a critical point in time, a juncture between a traditional and conservative past and an exciting and truly transformative future. It's a future that will require us to break with tradition to not only ensure success and sustainability, but in the new business to people or B2P era, we also need to be much better explaining what we do, how we do it, and the contribution we make to society. Rio Tinto has been in business for 145 years. Although what we do each day remains broadly the same, how we do it continues to change dramatically, and the pace of that change is accelerating across our industry. A career in mining responds to one of the most motivating drivers of human progress. Humanity has advanced, as Theo noted, on the back of exploration, discovery, and the hunger for new knowledge. We're a species perpetually fascinated by the quest for raw materials that today comprise our towns, cities, factories, and technologies, including, of course, our ubiquitous smartphones. We've built everything that we have, everything we see around us, from the mineral wealth won from the Earth's crust or from that ground upon the Earth's surface. We have an industry whose product underpins prosperous modern life. Let's reflect on what each of us has witnessed over the past 30 years. Our safety focus, intensifying and delivering ever lower rates of injury as we drive towards our goal of zero fatalities. Our industry remaking itself over and over by scaling up our operations and equipment in a way few outside our industry can comprehend. Our technologies taking giant strides forward so that things that were inconceivable when I started my career are increasingly commonplace. And new innovations coming from adjacent industries having a profound impact on ours, such as communications, cloud computing, and now the rise of data science, machine learning, and artificial intelligence. This ongoing innovation and transformation is what we do for a living. The story is not well understood outside our industry, and we need to start to change what are very often out-of-date perceptions. The days of kicking over a rock to find a major gold seam or spying the edge of the Hunter Valley's coal reserves from sea are mostly behind us. That which is easy to find has been found. The challenge for explorers is far more complex. We know intuitively that there are vast reserves of minerals and metals waiting to be found. However, our common sense and evidence suggests only in increasingly deep, remote, and difficult places. So we refine and develop our science to meet that business challenge. The more difficult the discovery and the seemingly impossible the extraction, the more our industry rises to meet the challenge. We have an impressive track record of solving the problems of maintaining and increasing production of the minerals and metals that are essential to human development. I think it's important for us and also the broader community to always bear in mind what all this means for our living standards. Broadly speaking, we in the West enjoy an amazingly high quality of living. We have reliable energy, clean water, safe food, modern hospitals, air-conditioned office towers, good schools, and comfortable homes. Everything I've described, modern, prosperous life, is built out of the materials supplied by our industries or is incorporated into technologies reliant on those materials. When I was young, China was a byword for poverty. It had more than 600 million people in the 1960s, and we understood that most lived hand-to-mouth, supporting their families by manual cultivation. Bad seasonal, climatic, and other changes routinely led to famines that meant millions suffered or perished. It's staggering to think of this now. In the last 3 decades, this colossally large nation has totally transformed itself into an economic powerhouse rivaling the world's largest economy, the USA. It now has around 1.4 billion people and has lifted the vast majority of them from that precarious agrarian existence into a middle-class comfort that we all recognize. The Chinese of today mostly live in vast modern cities, just like us. It's roughly equivalent to 300 years of European industrialization multiplied by 1 billion or so people and delivered within 30 years. And nearly all of the foundations for this progress come out of mines, and a very significant proportion from mines located here in Australia. It has been built from steel and copper, from gypsum, gravel and sand, from bauxite, alumina and aluminium, and most recently from silica, rare earths, nickel and lithium. China's recent history is the compressed high-speed slide deck for showing all of humanity how we got where we are and perhaps where we are going. So what of our approach? To do justice to our ore bodies today, we are guided by our 4 Ps framework: performance, portfolio, partners and people. And I will touch upon aspects of these today. We're a company driven to extract ever higher performance in safety and productivity using a combination of technology, innovation, and automation. We've made a commitment to our owners that we will deliver a step change in performance through our mine-to-market productivity drive. This is aiming to deliver an additional $5 billion of free cash flow from our assets by the end of 2021. In order to deliver this, we must transform the underlying productivity of our core assets, and we must transform ourselves organizationally to align to the work of the future and not to the work of the past. We pride ourselves on being pioneers in our industry. In the early days of Rio Tinto, 145 years ago in Spain, our pioneering was a bit more prosaic. But our history is full of pioneering activities, from building the world's first massive open-pit copper operation at Bingham Canyon in the US in the 1920s, through to the discovery in the 1950s of the Weipa bauxite deposit, the foundation for our Australian aluminium business. In the 1960s, we discovered and developed Mount Tom Price, which has delivered us today a world-class iron ore business in the Pilbara. And in the late 1970s, the discovery of Argyle allowed us to play a significant part in the global diamonds industry. We and the broader industry have much to be proud of. Today, we're pioneering in the fields of automation, artificial intelligence to help us address the many challenges of the future. Almost 10 years ago, the first driverless truck was loaded with ore at our Pilbara operations, and this quickly led to the development of our world-class autonomous haulage system, now increasingly augmented by autonomous drills, as announced 2 weeks ago. Today, we've grown our fleet significantly, and our remote operations centre in Perth controls more than 80 trucks from more than 1,500 kilometres away. We've now progressed to autonomous rail. AutoHaul is the world's first fully autonomous heavy haul train. We operate over 200 locomotives on more than 1,700 kilometres of privately owned track in the Pilbara, transporting ore from our 16 mines to 4 port terminals. Each autonomous train comprises 2 locomotives and some 240 ore cars, making them each 2.4 kilometres long. In essence, these are the world's longest and largest robots. To date, we've completed more than 3 million kilometres in what we call attended autonomous mode. We have about 65% of all trains operating in this mode, and the percentage is increasing by the day. We expect the system to be fully operational with full regulator sign-off later this year. AutoHaul is underpinned by what is known as the Driver Strategy Engine, an AI. This is an onboard, predictive, dynamic train system that safely and efficiently drives the trains. It uses data such as track topography, signalling information, and speed restrictions, as well as characteristics of the locomotives and ore cars to inform the driving strategy. Through this application, AutoHaul is delivering about a 6% speed improvement. This is not about technology for technology's sake. This is about improving performance and safety, productivity, and so to our bottom line. In recent trials, the autonomous trains delivered the product to the port nearly 20% faster than a manned train. An area of our business that is relatively new today, but which will reshape our future, is data analytics. We have a dedicated data science team that are working through these challenges. We are generating vast volumes of data every minute of every day, and as we turn on more sensors, this is growing at incredible rates. Rio Tinto has more than 60 operations and projects globally. The volume of data being generated is enormous. However, this ocean of data is close to worthless in its raw form, but with modern tools and by partnering well, we can extract intelligence and insights to help drive our business to greater success. We see tremendous value in connecting our industrial and corporate assets together, collating and analyzing data from drills, trucks, shovels, conveyors, trains, and ships. We currently track more than 4,000 vehicles across our operations in real time, 24/7. Haul trucks are a subset of this fleet, and each truck today has more than 45 electronic tags, which report data every few seconds. Across the entire fleet, we store more than 30 million geopositions per day. All this information is carried across our network and stored both within our data historians and in our data lake. So what do we do with all this data? This video shows our proprietary mine automation system known as MAS, which is in place at 98% of our operations. It allows us to combine our data to deliver operational insights in real time. It's a world-class fusion database with artificial intelligence and machine learning capabilities embedded. This system has been developed through a decade-long partnership with the Australian Centre for Field Robotics at the University of Sydney. Detailed data about the ore body is used to improve planning and resource utilisation rates. Data generated by autonomous drills now feeds directly into ore body models. We have a better understanding of what grade is where before we mine, and also information on hardness for blast operation, blast optimization, or material handling for processing efficiency. The wealth of data supports powerful analytics tools. As the number of sensors on equipment grows, so does the opportunity. There is little doubt that the people with the best chance of yielding intelligence from our data may never have worked in our industry and may know nothing about mining. Geologists, miners, engineers, we all have a certain predisposition. We're all classically trained. We all understand the value of that training, and the models that underpin our business today has stood our industry in good stead for decades, but is no longer enough. To survive and prosper in the modern technological environment requires us to not merely gather and analyze our data, but to challenge our biases and reset approaches to really upend our modes of thought. We live now in an age of disruption, and it's folly to think we can hide from it. If we don't disrupt ourselves, our own ways of thinking and operating, someone will do it to us. If you had asked me 10 years ago if I ever thought we'd be hosting a hackathon, well, I would have said, what on earth is it? And perhaps we're here to mine and not to play games. And I would have been wrong. For proof of that, I offer the hackathon we ran last year here in Sydney. It was an initiative of our Pioneer Lab. We created the lab to find, nurture, and accelerate groundbreaking ideas, from incremental tweaks to industry disruptors. We gathered 22 frighteningly clever and mostly young people from universities and from tech startups. We held them hostage over a weekend, feeding them coffee, donuts, pizza, and data. These appeared to be their chief dietary requirements. We divided them into 5 groups and threw them a challenge. The problem: haul trucks dump their loads at processing plants and should leave empty, but often some of the dirt sticks in the tray. I'm talking about tons at a time. We know of this as carryback, and it obviously reduces the capacity of the vehicle for its next load. On some of our sites, it costs us up to 5% of our haulage capacity. So it was, out with laptops everyone, how can we solve for carryback? The first thing to note is that every group came up with an entirely different approach. They asked different questions and used different thought processes. Secondly, they all used algorithms and machine learning software to learn and improve functionality. So the same basic toolkit, but 5 completely different takes on the problem. There is so much we can learn from this simple exercise. Will we do it again? Absolutely. Some of the solutions increase the accuracy of predicting carryback to well above 90%. But that wasn't the only payoff. For the participants, a weekend of analytics and problem solving is their idea of fun. They had a great time, and they came away thinking, who knew mining was cool, and who knew there could be jobs for me in mining? But let's also think about our IT world for a minute. It is in the area of compute and storage, as well as systems and tools that are redefining our world. The Internet of Things, IoT, is transforming our world, and the pace is accelerating. We are seeing an explosion in the number and type of sensors being deployed to measure and monitor nearly anything we can think of. McKinsey has estimated that around 3 billion new sensors will be deployed globally each year between now and 2020. And yes, I said 3 billion. The rise of cloud computing is changing how we deploy computing and systems across our assets. This, linked with new communications technologies, is allowing us to move vast amounts of data between our assets to major cities and globally. This allows us to place real-time information into the hands of operators in the field where it is needed. Likewise, the rise of cloud computing is doing away with traditional approaches of company-owned IT environments. We can now partner with providers to manage all aspects of storage, compute, and support, so we can focus on our core business of mining. A recent example from our exploration team provides a useful insight into what has recently become possible in the area of data analytics. A new satellite was recently found to provide superior data from which our exploration teams had built an algorithm that maps geology and certain styles of alteration. Early tests showed exciting potential, but when the team sat down, they realized that using their normal methods for processing, it was going to take us about 50 years to grind through it all. That did not sound very agile. Like good industrious explorers, they came up with a solution to build a computing cluster, and for several $1 million, they could reduce this time down to about 11 years. Management said no. Go speak to our data science team. The data science team worked with one of our cloud providers to tweak the code. They uploaded close to 1 petabyte of data, 1 million gigabytes, into the cloud and processed these data in around 11 hours, and for a compute cost of under $10,000. So in a matter of a couple of weeks, we took the task from 50 years to 11 years to 11 hours, and from millions of dollars to a few thousand. Now that is what I call progress. It's these types of use cases that are needed to reset our historic views on computing power going forward. We now have unfettered access to very cost-effective hyperscale computing power. And this is why building these data lakes and building credible data science capabilities is becoming mission critical for our industry. Now I'd like to talk about how the digitally enabled future plays out. Our Koodaideri project is an iron ore development project being studied within our Pilbara business. It is planned to be our most advanced mine yet built. Through the use of digital design, advanced data and analytics, machine learning, control loop optimization, and automation, we will significantly improve how we operate and maintain this new mine. Through the use of digital twins, we will better interact and use the data we gather during design and operations. The digital twin will allow us to access real-time data in the field to support our operators and maintainers. Ultimately, Koodaideri will run as a part of an integrated system where we can integrate in real time the mine, process plant, and rail system, including AutoHaul. It will employ some absolutely leading-edge technologies and in a completely novel way. Again, this is not a case of technology for technology's sake. This intelligent mine will improve safety, optimize performance, and so attract the workforce of the future. It's a point of pride that we regard ourselves as industry leaders in partnering with the communities living around us to create tangible local benefits and to create advocates for our operations. This is intricate and sensitive work requiring patience, humility, and upfront awareness that you have a massive amount to learn about the traditions, cultures, and aspirations of our host communities. In my time with the company, I've had the privilege to live in several countries and to have worked in more than 45. Every one of these places presents its own unique set of social, cultural, political, and economic preconditions that have to be understood intimately if we are to explore or mine there with anything approaching long-term success. A key aspect of our license to operate, or what we prefer to be known as our partner to operate, is skills training. We recognize that some traditional roles will be disproportionately impacted by automation and modern work practices. As such, we've started to partner to help upskill and retrain key parts of our workforce so they can continue to play their role and have meaningful employment. The most recent example is our partnership with TAFE in WA, which is creating a new vocational curriculum suitable for jobs of the future. This will teach skills and competencies in robotics, data analytics, and digital inclusion. Technology can also help to better inform our host communities on what mining will look like. At our Amrun Bauxite project in the Northern Cape of Australia, we've been using virtual reality to show the traditional owners what the impact of construction and mining activities will look like before construction commenced. The pioneering spirit is strong at Rio Tinto, and we like to apply innovation across all parts of our business, including our new projects. This video shows the modular construction of the 1 kilometre Chith export facility at Amrun using 13 prefabricated pieces. It's the first of its type in the world and was done safer and faster and more cost effectively than by traditional construction methods. This modularized approach also eliminated more than 300,000 high-risk work hours on site, which would largely have been conducted over water. In 2004, Rio Tinto discovered a significant quantity of a new mineral called jadarite, located in Jadar in Serbia. Jadarite intriguingly has the same chemical composition as the fictional mineral kryptonite. Jadarite is part lithium and part borates, and not only has it never been discovered anywhere else on Earth, it's obviously never been processed before. Our team at our research centre in Bundoora, near Melbourne, have been working hard to develop the chemical process to turn jadarite into sellable products. So we're using technology from initial exploration through engagement with communities, through how we study and design new projects, how we construct those projects, and of course, how we productively operate those mines and plants. We're also focusing on how technology can